Okay, so the starting of this paper 4 is about the syllabus and how the exams, 1 hour 15 minutes exam, 6 to 8 structured questions, and 4.1 forces and equilibrium. And these are the syllabus. So I leave it to you to look through on your own, and we just move on to the next page. So this is the starting of the notes. Part 1, resultant force. So to find resultant force, we follow the following steps. So the first steps is to resolve the forces into components. Okay, so resolve into components. So which means what? For example, let's say you have the weight which act downward, the weight of the objects, which acts downward. So you can resolve it to two perpendicular components. When you resolve, of course, the meaning of the words resolve is you break down to two perpendicular components. So for this case, one of the component that we take is along the inclined plane, and the other one is perpendicular to the inclined plane. So how we get mg sine theta and how we get mg cos theta? So let's say we take a look here. Okay, so if you have mg that act downwards, and let's see how we make use of this theta here. So for example, I draw the triangle. Okay, so the theta is there. Okay, so we have to know that here is 90 degree, and here is, after all, this is a right angle triangle as well. As you can see here, this is a right angle triangle. So if you have a right angle triangle, the total angle is 180 degree. So 180 degree minus 90, we still have 90. Then 90 you minus again with theta. So the remaining angle is 90 minus theta. 90 minus theta. Okay, so now we build a triangle in this way. In order to do resolutions, we build a triangle in this way. A right angle triangle. Okay, so together with this mg, so they form another right angle triangle. So we look at this blue color right angle triangle. So first of all, we focus on this angle. So as you can see, the inclined plane and the line that I show here, they are perpendicular to each other. So we should expect 90 degree here. 90 degree. So 90 degree minus with this one, we still have theta. So imagine 90 minus with 90 minus theta, we still have theta. So that is the angle over there. So that is theta. So knowing this as theta is very important, because once you know this is theta, so what can we do next is, once you know this is theta, right, we can do resolution, which means we can do mg cos theta and mg sin theta. So how we do it? Let's take a look. Okay, let's say now I use black color. Okay, so the component here is where one is perpendicular to the inclined plane, the other one is parallel to the inclined plane. So we start off with the one that is perpendicular to the inclined plane. This is the inclined plane. Okay, so perpendicular to the inclined plane is where we have to consider adjacent over hypotenuse. Adjacent over hypotenuse. So we make use of cos. Okay, we make use of cos. So cos theta equal to adjacent. So let's say the adjacent, I call it x. So adjacent over mg. So at the end, you bring the mg over, you get mg cos theta. So that's why we get the perpendicular, as you can see in the note here, mg cos theta. So the perpendicular is mg cos theta. So whereas the other one, the component that are perpendicular, or that are parallel to the inclined plane, is actually the opposite of the angle. So the opposite, let's say I name it y. So we can make use of the opposite as well as the hypotenuse to work out y. So since it involves opposite and hypotenuse, so we can use sine. So imagine that sine theta equal to opposite over hypotenuse. Then you can get the y by moving mg to the left. So you get mg sine theta. Okay, mg sine theta. So that is how we get the component that is parallel to the inclined plane. Okay, so now this is mg sine theta. As you can see here, I put it here because I want to solve the triangle easily. But once you get the value, you can always transfer it here for better illustration. So mg sine theta, we can transfer it there as you see what they do here. Okay, they transfer from here, they transfer it to this side. Okay, so this is very important because the objects that are located on the inclined plane, right, the acceleration is affected by this one. Okay, so whether the objects has forces in equilibrium or not equilibrium is affected by this force, this component. Okay, so I already explained how to do resolution. So now let's look at the steps again. So the steps here, resolve the forces into components, where I already explained, which are the mg cos theta and mg sine theta. We already resolved that. Find horizontal resultant. Find vertical resultant. For our case is find the forces along the plane. Find the forces perpendicular to the plane. Okay, so the horizontal and the vertical is for objects on the horizontal plane. For example, let's say if you have an object here, so on the horizontal plane, then horizontal and vertical will be more important. Okay, will be relevant. Relevant. But for inclined planes, the relevant components will be the component which is parallel to the plane and perpendicular to the plane. Okay, so parallel to the planes will affect the acceleration of the objects. Perpendicular to the plane will affect the normal. Yeah, the normal is equal to mg cos theta. So yeah, do you know that? Where I better write down the normal reaction. Normal reaction is, or the normal force is equal to mg cos theta. So we will come to this normal force later, where normal force is used to find the friction. Okay, it's used to find the friction. We will come to it later. So we just leave it like this first. Okay, now at the end, you can find resultant force and directions. Okay, you can find resultant force and direction. Okay, so resultant force and direction. For example, right, once you get the horizontal resultant, you add up all the horizontal forces. Okay, so you get the horizontal resultant. So imagine something like this. You get the horizontal resultant, F horizontal. Then you get all the vertical resultant. Then you join up like this. The vertical resultant, perpendicular to each other. Then you want to find the resultant force. It will be the hypotenuse of the triangle. So normally we involve Pythagoras Theorem to find the resultant force. And after that, you have to find the direction of the resultant force also. So we will put an angle here, and we say that it is how many degrees from horizontal. Okay, so let's say theta. Theta, we put a theta there. then normally we use, we already know the vertical force. We already know the horizontal force. So we take tangent, tangent is opposite over adjacent. Then we inverse tangent and get the angle, the theta, which represent the direction of the resultant force. Okay, so these are basically the steps. Now we look at number 2. And again, this is for the basic one. Horizontal and vertical are involved. So now number 2 is about an object on a slope. Could be resolved into component along the slope. Along the slope is this one. I already explained. Mg sine theta. And components perpendicular to the slope. So I already explained also. Mg cos theta. As shown below. So you see the resolution. And then the question here, what is the resultant force for this object if the surface of the slope is smooth? So if the surface of the slope is smooth, that means there is no friction. No friction. This plane has no friction. The object moved down because of the mg sine theta. No other forces that oppose it. Friction oppose the motion. So there is no value. Okay, so if they say what is the resultant force for the object if the surface of the slope is smooth, state the direction of the resultant force. State the direction of the resultant force. So this is the direction. Okay, so the resultant force is mg sine theta. Okay, so the answer for this, okay, we write down here the resultant force. The resultant force is mg sine theta. Okay, state the direction of the resultant force. So we just say down the slope. So down the slope. So that is all about the second page. Okay, so this is resolving it into component. So let's see one question. Okay, one question. We see the past year questions. Okay, so in order to do the past paper, so we need to know one more concept, which is friction. Okay, which is friction. So let's learn friction first. I just tell you briefly about frictions, which is relevant to the inclined plane, so that you know how to do it. Okay, so then we can look at past paper. Like what I said just now, if there is a friction, the friction will oppose the motions. Okay, the motion. So logically, this object will slide down. So friction should act upwards. Okay, now in order to take this, let me draw again somewhere down here. So I draw a triangle again. And this time, let's say this is a rough surface. Rough surface. So this is the object on the inclined plane, and this is theta. So again, the object will have weight that act downward, mg. So if you have remember the components, that will be good enough. This is going to be mg cos theta, and this is going to be mg sine theta. These are the component after resolution. And since this is a rough surface, so they have to give one information, which is called the coefficient of friction. With coefficient of friction mu. So they have to give this constant, coefficient of friction. And we had to use frictional force formula at the same time. Frictional force is equal to mu r, where the r is the normal reactions or the normal force. So sometimes it is represented as n. Okay, as you can see the note just now, the note use n. Okay, as you can see above, they use n, but you can also use r. Okay, so F equal to mu r or F equal to mu n, capital N, so it's just fine. Okay, so what we need to do with this frictional force is you have to think about it in this way. Okay, you have to know that the R acts in these particular directions, as you can see the diagram, which is coming out from the inclined plane in 90 degree. So we have to know that the R is mg cos theta. R is mg cos theta. And after that, with this value of R, why R equal to mg cos theta? Because there is an equilibrium. There is an equilibrium between this direction and this direction. Equilibrium. So equilibrium means the forces balance off, So the force that act downwards, act this way, is balanced off by the force that act that way. So that's why the normal reaction is equal to mg cos theta. Okay, so balance or equilibrium. So once we get that, now we can find the frictional force by doing so. We can take frictional force equal to mu mg cos theta. So the R is replaced by mg cos theta. So we have mu mg cos theta as the frictional force. So it acts in the opposite way, which is like this, mu mg cos theta. So it acts in that way, opposing the motion. So imagine that, or assume that the object is having the motion that act downwards. That act downwards. Okay, so now what to do is we have to apply Newton's second law. Newton's second law that we learned in physics, we have to apply it here. So according to Newton's second law, we have resultant force equal to ma. Resultant force equal to ma. To find the resultant force, we take, as we know, the object is moving down the slide, moving down the slope. Okay, so we take down the slope as positive direction, up the slope as negative direction. So to find the resultant force, I'm going to use down the slope, which is positive directions, and then up the slope, I have to minus because I assume that is a negative direction. Cos theta equal to ma. So that is how we make use of Newton's second law, and by doing this, we can find out the acceleration. Okay, we can find out the acceleration of the object. Okay, by applying Newton's second law. So with this information, it will be enough for us to do past paper already. So let's take a look at the past paper that we can do. So let's say we do a short question first. And let's say this question, we do it together. Okay, so we look at page 6. Okay, so let's look at this. Page 6. Okay. A basket of mass 5 kg slide down a slope incline at 12 degree to the horizontal. Okay, 12 degree to to the horizontal. So let's say I draw out the diagram. Okay, so let's say like this. Okay, 12 degree. So the object is here, which is a basket of 5 kg. So we know W equal to mg. So W equal to mg. So when I said 5 kg, so we do 5 times 10. The G is 10 in mechanics. It's not like physics, they use 9.81. So in mechanics, we use 10. So we get 50 Newton. So 50 Newton is the weight that acts downward. 50 Newton. Okay, now let's see the question again. The coefficient of frictions between the basket and the slope is 0.2. So that is the mu. Mu equal to 0.2. So we will use mu to find the frictional force, like what I said just now. So here, part 1. So the question said, find the frictional force acting on the basket. Frictional force. Okay. So to find the frictional force, again, we have to do resolutions. Okay, so let's draw it out here. So we know this is mg cos theta, and we know this is mg sin theta. Okay, so we have mg cos theta, mg sin theta. To find frictional force, we need the R. Okay, and we know that this R and this mg cos theta are in equilibrium. Okay, are in equilibrium. So in that case, they are equal to each other. So let's look at our working here. R is equal to mg cos theta, where mg is found 50, cos 12 degree. Okay, so we get R already, and then we use frictional force formula, mu times R. So the mu is 0.2, the R is 50 cos 12 degree, and then we press calculator for this case, and we will get 9.78 Newton. So that is the frictional force. We get 2 marks only. By using F equal to mu R, so we get 2 marks. Okay, so the first part done. Now let's see the second part. Determine whether the speed of the basket is increasing or decreasing. Okay, so which means increasing means it is accelerating, or decreasing means it is decelerating. Okay, so we need to find out the component forces that act along the plane. So like what I said, the frictional force acts opposing the motion. Okay, which is here. 9.78 Newton is the frictional force. Okay, now what we can do is, for the component forces along the plane, we use Newton's second law. Okay, or without Newton's second law, we just look at the component, it will be enough already. So we want to find the resultant force along the slope. Okay, so down the slope is mg sin theta. I assume this is positive direction. Going up the slope is the frictional force. Okay, now I substitute with value. So the mg is 50, theta is 12, frictional force 9.78, and then I just count this. So I get 10.4 minus 9.78 So 50 sine 12 degree 10 point. Let's say I put two decimal places, which is 10.40 minus 9.78. So I get 0.662. 0.62. Okay, or if I keep all the decimal, it will be 0.616 in terms of three significance. Okay, so if you get a positive value, if you get a positive value, imagine that resultant force equal to MA. If this is positive, this is going to be positive, which means accelerating. So if you get negative for the resultant force, then your A will be negative also. So that is decelerating. So we can conclude already, this is accelerating. But we follow the wording of the question. The question said the speed of the basket is increasing or decreasing. So accelerating means speed is increasing. So we just write speed is increasing. The speed is increasing here. So this is the simplest question. Okay, the simplest question that we have for now. It won't be so easy actually. This is just a short question. Okay, we have a more difficult one. And most of the time, you should get yourself ready with the more difficult one. So let's see another case, which is the more difficult one.